Hello, welcome to the Management Channel. Here we are going to discuss Decision Theory Part 2 and take a closer look at Decision Tree tool for making decisions. The break-even point is where the volume of an output at which the total cost and total revenue are equal, meaning that you've sold enough items to where now you've paid off the equipment and you are now actually making a profit on the part that you're producing. A break-even analysis is a technique for evaluating process and equipment alternatives. The objective is to find the point in dollars and units at which costs equal revenue. It requires an estimation of fixed costs, variable costs, and revenue, meaning that you do this ahead of time. Fixed costs are costs that continue even if no units are produced. For instance, taxes, overhead, depreciation, debt, any mortgage payments or lease payments. Variable costs are costs that vary with the volume of the units produced, like labor, material, utilities that are dedicated to this production, and contribution is the difference between the selling price and the variable cost. So looking at this graph, you can see here that the fixed cost is here, and the variable cost is there, and the total cost time is up here. So here is where you see your break-even analysis is back here. By doing the formula, you realize that at the beginning you're going to lose money, but at a certain point here that would be almost 500 units, you would start to make a profit. So hence the break-even analysis or break-even point occurs when the total revenue equals the total cost. Or the price per unit equals the fixed costs plus the variable costs. We recommend you use this formula over here to the right. So let's take a look at an example. Our fixed costs are $10,000. Their direct labor is $1.50 a unit. Material costs are 75 cents a unit. And we're going to sell it for $4. So we have 10,000 divided by 1 minus the combination of $1.50 plus 75 cents, which would be $2.25, divided by $4, and equal $22,857.14. That's the total break-even point for cost. The units would be this way. 10,000 divided by the selling cost minus the cost to make it, which would equal that you have to make 5,714 parts before you even break even and start to make a profit. So here you can see from the chart you're losing money over here, and on the right is where you start to make money because the break-even point is at 5,700 parts, and the cost is a little over $20,000. Cash flow is the difference between cash received from sales or other sources and cash outflow that is paid out for labor, material, overhead, and taxes. The present value, or the sum in current value, of all future cash flow of an investment proposal. A general approach to decision making for a wide range of operations and management decisions is the decision theory. It works for capacity planning, product and service design, equipment selection, and even location planning. Characteristics of suitable problems, use it for there. Use it for characteristics of decisions that are required for using decision theory, which would be a set of possible future conditions that will have a bearing on the results of the decision. It could be a list of alternatives from which to choose, or a known payoff for each alternative under each possible future condition. So the steps are: first, identify the possible future state. Then develop a list of possible alternatives. Estimate the payoff for each alternative for each possible future state of the nature. And if possible, estimate the likelihood of each possible future state of the nature. Then evaluate the alternatives according to some decision criteria and select the best alternative. So again, identify the problem, specify objectives and criteria for solution, develop suitable alternatives, analyze and compare the alternatives, Select the best alternative and then implement it. Monitor to see if that desired result is achieved. Very important. Now, errors could be the failure to recognize the importance of each step, or maybe skipping a step. Failure to complete a step before jumping on to the next step, and the big one is a failure to admit you made a mistake. Also, how about an inability to make a decision? There are three general environment categories. Certainty, which is environment in which the relevant parameters have known values, we know for certain. Risk, environment in which certain future events have probabilistic outcomes based on a probability factor. And uncertainty, the environment in which it is impossible to guess or assess the likelihood of various possible future events. A decision tree is a schematic representation of the available alternatives and their possible consequences. It's composed of nodes, decisions represented by square nodes, and chance events represented by circular nodes. There are branches, there are alternatives, branches leaving a square node. Chance events are branches leaving a circular node. And you analyze from right to left. For each decision, choose the alternative that will yield you the greatest return. If chance events follow a decision, choose the alternative that has the highest expected monetary value or the lowest expected cost. So it's particularly useful when there are a series of decisions and outcomes which lead to other decisions and outcomes. Application of design decision trees to product design. The procedures would be include all possible alternatives, and don't forget to add the nature step of doing nothing. Enter payoffs at each branch, and determine the expected value of each branch. Then prune the tree to find the alternative with the best expected monetary value. So here's an example. We want to purchase CAD, or do we want to hire and train more engineers? Or do we want to do nothing, just leave things as they are? So we have to make two states, the probability of high sales and the probability of low sales. Now for both branches, the probabilities have to be the same, so 0.6 for high in both branches and 0.4 for low in both branches. So here, looking at the decision tree, we see there's a possibility of $2,500,000 in revenue. The manufacturing cost is going to be $1 million. The CAD cost will be $500,000. So if we do have high sales and we purchase CAD, we're going to net $1 million. But if we have low sales, the revenue is only going to be $800,000. The manufacturing costs will be $320,000. The CAD will still be $500,000, but we'll be operating at a net loss of $20,000. And you can see the formula. So by doing the EMV, 0.6 times $1 million net plus 0.4 times a loss of $20,000 equals $388,000. If we hire and train engineers following the same scheme of thoughts with the same numbers, we're going to net $25,000 on low sales, but only $875,000 in high sales. Hire and train the engineers is $365,000. Another example, EMV and capacity decisions determine states of nature, future demand, and market favorability. Is analyzed using decision trees. For instance, a hospital supply company has 4 alternatives. Market favorable, large plant, make a medium plant, make a small plant, or do nothing. So here we see the different costs involved. And we do the figures. Large plant would net us an EMV of minus $14,000. A medium plant would net us a positive $18,000, and a small plant would net us $13,000. So the best decision here would be the $18,000 or make a medium-sized plant. Even with market unfavorable, it's still not bad for a loss. So I hope that helps a little bit with decision tree thinking. It is a complicated process, but if you follow it right, it can help you make the best decisions. Thank you for watching and have a great day.